Hi, I'm Alex from LFP Marine. I'm going to explain what makes a good marine lithium battery different from a regular household lithium battery. And that's important because the value of life and property at sea is much higher than on land. First of all, a marine battery is designed to work on moving vehicles, like a sailboat, under conditions of vibration and rocking at sea. In regular batteries, the cells are usually held together with sticky tape or simply placed in a compartment with thin metal separators. As a result, the cells have some degree of movement. In our Cruiser 314 batteries, the cells are first compressed with pressure plates at a specific force and then secured with straps into a single module to which all other components are attached. This module, therefore, is a single unit with no moving parts. The marine battery is designed to operate in conditions of high temperature and humidity from salty air. First of all components must be protected. That's why we use an IP65 rated enclosure made of plastic. Second, in high ambient temperatures, it's absolutely critical to minimize heat generation inside the enclosure because higher temperatures reduce the battery's cycle life. To reduce heat generation, we use cells and a BMS with low internal resistance. We also increased the cross-section of all wires and connecting elements inside the enclosure by 30%. We use the active balancing method, where cell voltage equalization is achieved by redistributing current rather than dissipating heat through resistors as in the passive balancing method. A marine battery is typically a battery designed for heavy, long-term operation in harsh conditions. And these harsh conditions shorten its lifespan. To extend the service life, first, we use cells with the maximum number of cycles, 8,000. Second, when assembling cells into a module, according to the manufacturer's guidelines, we apply compression, thereby increasing the stability of the electrode's operation. In regular batteries, actual compression is generally not used, and in that case, the real number of battery cycles will be significantly lower. We use a powerful BMS rated at 300 amps and wires with an increased cross-section of up to 75 square millimeters. A marine battery must have a certain load margin to ensure fault tolerance. This crucial arrangement is meticulously done so that in a truly critical and challenging situation, if one of several parallel connected batteries unfortunately fails, the significantly increased electrical load per remaining battery does not become excessively high and consequently cause the rest of the interconnected batteries to fail as well, thereby preventing a complete system shutdown. That's exactly why, in our battery, the BMS current rating is twice the recommended operating specifications. And of course, a marine battery must be as safe as possible. In regular batteries, all protective functions are implemented solely through the BMS. For example, to provide short-circuit current protection, a sensor measures the current. Then, the data is sent to the BMS controller. The system sends a command and turns off the MOSFET transistor. In other words, the execution of this protective function depends on the logic and proper operation of the BMS itself. At sea, an incident may occur in which part of the battery, for example, the BMS itself, is physically damaged. In this case, there will no longer be any short-circuit protection. That's exactly why we specifically added a fast current limiting fuse of the T class to our battery, as a 100% guarantee of short circuit protection even in emergency situations. We wanted to make this battery as convenient as possible for use on a boat, so we provided a quick and complete battery shutoff with the push of a button. Now, if you leave for a long time and leave the boat, you don't have to worry that the internal electronics will drain the battery. We don't just talk about how our batteries are built, we show it. Be sure to check out the video about what's inside. Goodbye.